After capturing fresh images of the interstellar object 3I Atlas, NASA's Mars Atmosphere and Volatile Evolution, or Maven, orbiter has mysteriously lost communication with Earth. The unknown anomaly that put Maven out of contact with NASA's Deep Space Network has raised alarms. As of December 6, 2025, Maven has been completely out of touch with Earth, and the cause remains unclear. This sudden communication failure came after Maven's critical observations of the object, raising questions about whether there is a connection between the orbiter's malfunction and its encounter with 3I Atlas, a rare visitor from outside our solar system. Maven was launched in November 2013, embarking on a mission that would stretch beyond the planet it was designed to study, Mars. In September 2014, it reached the Red Planet, where it entered orbit and began its detailed investigation of Mars's atmosphere, ionosphere, and how these interact with solar wind. This research has helped reveal how Mars, once a warmer, wetter world, lost much of its atmosphere over billions of years, becoming the cold, dry planet we see today. For over a decade, Maven's measurements and observations have been crucial in understanding this atmospheric escape process, including its detection of sputtering, a phenomenon where Mars's upper atmosphere is bombarded by charged particles from the Sun, stripping away its atoms. As an integral part of NASA's scientific endeavors, Maven's role extended beyond just studying Mars. It also served as a relay for other spacecraft and missions on Mars, including the Perseverance rover. Its ability to send back data from Mars was vital for ongoing exploration. However, its recent failure to communicate raises new questions. After taking a set of ultraviolet images of 3I Atlas, the spacecraft, operating well beyond the Martian atmosphere, encountered an unexpected anomaly that has left scientists and engineers searching for answers. The strange timing of the orbiter's failure, coming directly after its images of the interstellar object, has led some to wonder if there is a deeper connection between Maven's loss of communication and 3I Atlas itself. The spacecraft had successfully captured ultraviolet images of 3I Atlas using Imaging Ultraviolet Spectrograph, or IUVS, and provided essential data that added a new layer of understanding to the behavior of this interstellar object. The primary focus of these images was on detecting hydrogen atoms within 3I Atlas. The resulting images revealed a bright, fuzzy halo around the object, indicative of its hydrogen-rich environment. The most significant aspect of these images was the detection of hydrogen from three distinct sources. The first was from the object itself, appearing as a dim spot in the images. The second source was Mars' atmosphere, which showed up as a bright streak. Finally, interplanetary hydrogen, the same substance that permeates the space between stars, appeared as a dimmer streak. This ability to differentiate between these sources was groundbreaking because it allowed scientists to pinpoint the origins of the hydrogen they were observing. By measuring the speed of these hydrogen atoms, Maven was able to assign each source its correct origin. This achievement in itself was significant, offering scientists clues about the object's journey and its interaction with the solar system. The images also gave insight into the object's composition. Scientists had speculated about the nature of 3I Atlas since its discovery. Thanks to Maven's detailed observations, some of those questions were being answered. By examining the ultraviolet data, scientists hoped to gather clues about the object's makeup. The images could reveal the composition of the gases surrounding the object, providing evidence of its interstellar origins and the materials it was made of. This was essential not only for understanding the specific nature of 3I Atlas, but also for understanding how objects from other star systems behave when they pass through our solar neighborhood. As the object moves through our solar system, scientists are able to gain insights into the nature of interstellar matter, which is otherwise extremely difficult to study due to the vast distances involved. However, while Maven's images provided crucial data on 3I Atlas, the orbiter's loss of communication on December 6th left many questions unanswered. As Maven's final data transmission went silent, it became clear that the spacecraft had encountered an anomaly. The specific cause of the anomaly remains unknown, but it is suspected that the orbiter's systems might have been affected by an unforeseen disturbance, possibly related to the environment around the interstellar object. This has sparked interest not only in Maven's sudden malfunction, but also in the object object itself, raising questions about whether there could be something unusual about 3I Atlas that affected the orbiter's operations. 3I Atlas is, without question, a highly peculiar entity. Its journey through our solar system has been filled with strange and unexpected phenomena, leading scientists to believe that there may be more to this interstellar object than meets the eye. The object's trajectory, behavior, and physical characteristics have all raised questions that remain unanswered. One of the most significant anomalies surrounding 3I Atlas is its predicted closest approach to Jupiter on March 16, 2026. According to calculations, the object's closest approach will occur almost exactly at Jupiter's Hill radius. The Hill radius defines the region around a planet where it has dominant gravitational influence over objects. It is a region where objects can be captured by the planet's gravity. The fact that 3I Atlas is predicted to pass so close to Jupiter is a highly unlikely event, especially given the object's high non-gravitational acceleration. This anomaly is of particular interest because it suggests that there may be forces at play influencing the object's path, which are not yet fully understood. Another anomaly worth noting is the extremely fine-tuned trajectory of the object. The timing and path of 3I Atlas's journey had brought it near several planets, including Mars, Venus, and Jupiter. This trajectory was so precise that it allowed the object to remain unobservable from Earth during its perihelion, the point at which it passed closest to the Sun. The fact that the object could follow such a specific path is statistically improbable, making it a subject of intense interest for researchers. This anomaly raises questions about the forces governing the object's movement and whether its path is the result of natural gravitational influences or something else entirely. Further adding to the intrigue is the object's mass and speed. 3I Atlas is far more massive and faster than previous interstellar objects, such as 1I Aomao and 2I Borisov. Its large mass and high velocity make it an outlier among interstellar objects, which typically travel at much lower speeds. The sheer size and speed of the object suggest that it may not have followed the random distribution typically seen in interstellar objects, and its behavior could be influenced by factors that are still not well understood. One of the more striking features of 3I Atlas is the sunward jet or anti-tail it displayed. This jet is not easily explained by geometric perspective alone, making it a curious anomaly in the study of interstellar objects. Comets, for example, typically display a tail that points away from the sun due to the pressure exerted by solar radiation on the particles in the comet's coma. This solar wind pushes dust and gas away from the object, forming a tail that always points in the opposite direction of the sun, a behavior observed in numerous comets and small solar system bodies. However, 3I Atlas showed an entirely different phenomenon, an anti-tail, or a jet that seems to point directly toward the sun. This sunward jet challenges the conventional understanding of how such objects should behave when they pass close to the sun. The tail of most comets is created by the sublimation of volatiles like water ice as the object nears the sun, releasing gas and dust into space. Solar radiation and the solar wind then push these particles outward, forming a tail that stretches behind the object. This tail points away from the sun, and its direction is determined by the interaction of the comet with the solar wind. The particles are pushed outward, and the tail gradually becomes more diffuse and extended as the comet moves away from the sun. In contrast, the behavior of 3I Atlas's anti-tail is perplexing because it appears to show a jet of particles pushing toward the sun rather than away from it. The anti-tail does not conform to the typical behavior seen in comets or any other known celestial objects. Several possible explanations have been proposed, but none fully account for this unusual feature. One hypothesis is that the anti-tail might be the result of a highly energetic outgassing process unique to 3I Atlas. Unlike ordinary comets that release gases primarily through the sublimation of water ice as the object nears the sun, releasing gas and dust into space, this object may be composed of a different mixture of materials that react differently when exposed to the sun. If 3I Atlas contains more volatile compounds than typical comets, or if it contains materials that do not sublimate in the same way, the release of gases could produce an outflow that behaves differently from the usual patterns of cometary tails. Another possibility is that the solar wind itself could be interacting with the particles emitted by 3I Atlas in an unusual way. The object's trajectory and speed could be factors that make its interaction with the solar wind more complex. The high velocity of 3I Atlas, combined with its irregular composition, may cause the outgassing to be channeled or directed in a way that creates a jet aimed at the sun. This phenomenon is rarely observed in other interstellar objects, and it might indicate that 3I Atlas is not simply an ordinary comet, but rather an object with properties that are still not fully understood by current models of cometary physics. The composition of 3I Atlas's gas plume is another anomaly. Unlike most comets, which exhibit a high proportion of iron relative to nickel, the gas plume of 3I Atlas shows an unusually high amount of nickel compared to iron. Additionally, the object's nickel to cyanide ratio is not in line with what has been observed in other comets. This chemical composition raises questions about the origins of 3I Atlas, suggesting that its formation process may have been different from that of other solar system bodies. The object's retrograde trajectory is also noteworthy. Unlike most objects in the solar system, which follow prograde orbits that align with the sun's rotation, 3I Atlas follows a retrograde trajectory. This is a statistically unlikely feature for an interstellar object, adding another layer of mystery to the object's behavior. The fact that its orbit aligns so closely with the solar system's ecliptic plane is a further anomaly, one that has captured the attention of astronomers. Beyond these major anomalies, there are also medium and minor anomalies associated with 3I Atlas. For instance, the object's arrival direction is notably close, within about 9 degrees, to the direction of the famous WOW signal, a radio signal detected in 1977 that remains unexplained to this day. The object also exhibits extreme negative polarization, a feature that is unprecedented among known interstellar objects. This unusual polarization could be related to the object's anti-tail, adding yet another layer of complexity to its behavior. As 3I Atlas continues its journey through the solar system, scientists remain captivated by its many anomalies. Whether these strange features are the result of natural processes or something more extraordinary, the object has proven to be one of the most fascinating objects ever observed by humanity. Maven's unexpected loss of communication after capturing images of 3I Atlas adds a layer of mystery to the already puzzling nature of the interstellar object. As engineers work to restore contact with the orbiter, the connection between Maven's malfunction and the object's anomalies remains speculative, but the timing of the two events is striking. Whether Maven's systems were impacted by the object's unusual properties, or whether the anomaly is purely coincidental, is still unknown. However, the investigation into both Maven's failure and the behavior of 3I Atlas is sure to keep scientists occupied for years to come as they continue to unravel the mysteries of this rare visitor from another star system.
The thing is that our paper and the original paper are the only discussions on this issue. So when people say it's a comet, they don't attempt to explain the anomalies I mentioned. They just ignore them. Okay? And that's what you should ask NASA officials when they say we are confident it's a comet. Okay, how do you explain the large mass of the object? How do you quantitatively, not just say, oh, comets are weird and some of them are unusual and therefore it's okay.
They're all different, right?
But that's not an explanation if you don't have enough mass in rocky material in interstellar space to accommodate the delivery of such a package over the past decade. You need to explain that. You can't just ignore it. This is not politics. We are talking about science here.
Right.
And you have to think. You can't just... So you can't just be a bureaucrat that makes statements and everyone should believe you because of your authority. That's not the way science is done. We all know that the Church, the Vatican, apologized and admitted 350 years after Galileo died that he was right. That was a very bad public relations stunt. Imagine NASA coming up and saying it's definitely a comet and something ends up being a technological relic. How would they look? Right. So if you want to be sincere and honest, you don't make some authoritative statements by bureaucrats. You go to the data and explain the anomalies. So if you want to say this is definitely something we understand, you have to explain why is there a glow ahead of the object in the direction of motion according to the image that you are showing in the same press conference.
Right.
I'm not saying about other images. Even your image is paradoxical.
And explain it to people. Explain it to normal everyday people that can't understand physics or can't or don't have a deep understanding of astrophysics. We are human beings that live on the Earth. Why can't we understand this?
Exactly. No, so that's exactly my point. You know, people ask me, why are you putting a significant fraction of your time explaining to the public? And I say it's because, you know, I'm puzzled just like the public. I don't feel myself different than the public. I just have the privilege of using the scientific method to answer questions that I'm curious about. And I take, I'm very respectful of the curiosity of the public.